All right, let's talk Java. If you're a developer, you definitely know the feeling. You've written this perfect, elegant code, and then bam, a wild null pointer exception appears and everything just grinds to a halt. But what if we could actually manage that chaos? In this explainer, we are going to do just that. We're going to master Java exception handling together.
And look, it's a question we've all asked ourselves, right? Java's exception handling is incredibly powerful, but man, it can feel like you're walking through a minefield. Our goal isn't just to stop our apps from crashing. It's about building software that's tough, easy to maintain, and predictable. So let's dive in and make sense of it all.
So here's our game plan. We'll start with the absolute basics. Then we're going to jump right into the great checked versus unchecked debate. We'll look at the tools you have, the common mistakes you need to avoid, and even get our hands dirty, creating our own custom exceptions. And to wrap it up, we'll see how the pros do it in a team setting. Let's go!
Okay, first things first. To navigate any kind of complex system, you need a map. And in the world of Java errors, that map is the exception hierarchy. Seriously, understanding this structure is the most important first step you can take.
So, right at the top of this whole family tree, we have a class called throwable. Think of it as the great-great-grandparent of every single thing that can possibly go wrong in your Java code. Doesn't matter if it's running out of memory or a file not being found, it all starts right here.
Now, throwable has two main children, error and exception. And this is a really critical distinction. Error means something catastrophic has happened, like a Stack Overflow error. Your app is probably toast. You can't recover from it. Exception, on the other hand, well, that represents things your application can and probably should handle. This is where we as developers are going to spend most of our time.
And that brings us to probably the most debated, most talked about topic in Java exception handling. You see, the exception class itself is split into two big categories that totally change how you write your code: checked and unchecked exceptions.
This table really breaks it down. The main difference? The compiler. For checked exceptions, like an I/O exception from a missing file, the compiler forces you to deal with it. Why? Because it's usually caused by an external factor you can't control. Unchecked exceptions, on the other hand, like the dreaded null pointer exception, are almost always bugs in your own code. The compiler lets them slide because the expectation is that you'll fix the bug, not just put a band-aid on it.
All right, so we've got the theory, we've got our map of the exception world. Now let's open up the actual toolkit that Java gives us to deal with all this stuff.
Look at the code on the left. That's the old try finally block. It works, but it's clunky. And what happens if fr.close itself throws an exception? It gets messy. Now look at the right. The modern try with resources statement is just so much cleaner. Any resource you declare in those parentheses gets closed automatically, no matter what. It's safer, it's easier to read. Honestly, this is the way to go, every time.
Now, throw versus throws, this one trips people up all the time, but it's actually pretty straightforward. Think of it like this. Throw is an action. You are actively, right now, throwing an exception inside your code. Throws, on the other hand, is a warning label. You put it on your method signature to tell other developers, hey, be careful, this method might throw one of these exceptions, so you better be ready to handle it.
Okay, so knowing the tools is half the battle. Using them right, that's the other half. Every developer makes mistakes, but we can learn from them. Let's go over some of the most common pitfalls in exception handling so you can sidestep them completely.
This right here, catch exception E, is probably the #1 mistake I see. It's like trying to catch one specific type of butterfly with a giant fishing net. Yeah, you'll catch it, but you'll also catch birds, bees, and maybe a null pointer exception you had no idea was even there. Always be specific in your catch blocks. It makes your code way more robust.
You know, a user on Reddit put it perfectly. If you can't actually do something meaningful about an exception, just let it go. Let it bubble up to a part of the code that can handle it. Just catching it to log it and then do nothing is often worse than not catching it at all because it silences a problem.
And that leads us to this anti-pattern: logging an exception and then immediately rethrowing it. All this does is create noisy, repetitive logs that are a nightmare to read. Remember, the stack trace already tells you where the problem started. The best practice? Wait to log the exception until you're at the point where you're actually going to handle it for good.
This is so important. Sometimes you'll catch a low-level exception, like an SQL exception, and wrap it in your own custom exception. When you do this, you absolutely must pass the original exception in as the cause. If you don't, you lose the original stack trace, and debugging becomes a million times harder. It's one simple line of code that can save you hours of pain.
So, as your apps get more complex, you'll find that Java's built-in exceptions, they just don't cut it anymore. They're too generic. This is where you can start forging your own tools by creating custom exceptions that describe your specific business problems.
And you might think making your own exception is complicated, but it's actually super simple. You just create a new class, have it extend an existing exception, and then add a couple of standard constructors. That's it. This lets you make your code so much clearer. Instead of a generic error, you can throw something super specific, like a negative balance exception. It's self-documenting.
So far, we've been talking about what you as an individual developer can do. But software is a team sport. How do we make sure everyone on the team is handling exceptions the same way? Let's zoom out and look at the guild rules that projects use.
Just take a look at this mind map. It comes from a survey of professional developers, and it shows all the different guidelines teams come up with for handling exceptions. It covers everything from when you should throw an exception to whether you should prefer checked or unchecked types. It really shows how deep this topic can get in a real-world team setting.
But here's the really wild part from that same research. For over half of the teams surveyed, these super important rules are completely implicit. They're just understood, not written down anywhere. Only 16% of teams actually document their guidelines, and you can imagine how much confusion that causes, especially when someone new joins the team.
So if all these rules are just understood, how does anyone actually enforce them? Well, for most teams, it comes down to good old-fashioned code reviews. It's a very human process where developers check each other's work and pass on that tribal knowledge. And that really brings us to the main point here. Good exception handling is a team sport. It's not just about you writing clever code in isolation. It's about having clear, shared, and preferably written rules that everyone on the team agrees on. It will save you so many headaches in the long run.
So, I'll leave you with this question to think about. On the project you're working on right now, are your exception rules crystal clear and written down? Or are they just floating around in the air like an unhandled exception just waiting to happen? Thanks for tuning in.